Hello everyone. This is the HMI of the car parking system that me and my team built, which is really simple. We have a gate in. When you click the gate in button, the gate would open, and then after that it will hold for a few seconds, and then it will come back on, and it will close it back. And then here the same thing. We have a in and out gates. And then inside this gate, we have a parking slot. Let's say for this gate, we keep as 6 for the OKU and 2 for the OKU and 4 for a normal case. So what basically is, imagine that you're in a shopping mall and you're going inside the shopping mall and look for the parking. The first thing you will do is you will see the board, this one, and how much parking available. This one I explained. So what you do is normally you click in, and then after that you go in your parking slot, and then after that there will be the light. If you're occupied, the light would be turned off. That is a very normal case. So for the PLC part, let's say this is for the stop button to start the whole operation. Stop is similar. To stop all the whole operation. Reset, I add the reset button because in case if something have like sometime we have a bug, like the number is not changing, they're having a constant number here, so you need to reset it, kind of like refreshing your computer. So this is the kind of like a dashboard. It will say how many parking available inside this parking slot. For this case, if nothing is occupied, it's gonna say 6. And then before you come inside the gate, you will see, for example, 6 parking available. Let's say if you keep on occupying all the 6 parking slots are occupied, it's gonna be 0. And then after that it will be full. And one more thing, when it's full, I add some kind of, let's say we want to add something, make it more smarter so that you cannot go inside, so which means it's already full, so you need to take another parking. Okay, before I start explaining about the flowchart, I want you to familiar with the register D01, which is a occupied car parking spaces, which means how many cars are occupied. And then D102, it's available car parking space, which means how much still left inside the parking space. And D103 is a total parking space, which means it's a combination of occupied and the available one. So the process is very simple. Okay, you have a start, and then once you start, I'm gonna move number 6 to the D103, which is a total parking space. This number 6 you can change. If you have like 10, then you can put 10. Yeah, what we do is after that we're gonna start counting the bit from just now, the sensor here. Yeah, this one we're gonna count how much how many input are on. When it's on for 1, they're gonna return the value of 1. If they on for 2, they're gonna return the value of 2. So it's a bit counter, so they're gonna count the bit, how many bits are on, and they're gonna store that value in D101, which means occupied car parking space. So let's say we have occupied 2, right? Say 2 parking spaces are occupied, so they're gonna store 2 inside D101. And after that, what it's going to do is it's gonna do subtractions without carry. So in this case, without carry, because we're not interested in carry, which is like minus, positive minus. So what it's gonna do is available parking equal to D103 minus D101. So let's say we have right now it's here 2, and then after that our total parking space is 6. 6 minus 2, we're gonna get the 4, and it's gonna show inside a D102, which is available car parking space. This is the only register that we're interested in. So let's say 4, we want to show it to a car driver, telling them that we have full parking available inside our parking lot. So what it's gonna do is it's gonna decode it for a 7-segment display. We have 4, put it inside the decoder. The decoder will automatically decode like if you receive like 1, then it's gonna show the 1 into a 7-segment display. This one it's together with the Omron PLC, so you don't necessarily check the value now. It's if like this value you should show this, it's automatically which is quite nice. So it's gonna show the value of 4 and go here, and this one is for available and full. What it's gonna check is the occupied car parking is equal to total car parking, which means if not equal, it's still available. So yeah, gonna go back to this loop. If let's say you have 6 total parking space and you all 6 are occupied, it's gonna go full. Yes, it's already equal, so it's gonna go to here, and then after that it's gonna start the whole process. It's gonna be keep on looping and make it like a closed loop. This is our ladder diagram. It's very simple, and I add comment in each sections for documentations. So is that everyone who is reading the code, in case if they don't know what is going on, they can read up the comment and figure it out. So the first thing, I'll go through briefly, and the first thing is very simple. It's gonna start, stop, and I use the latching method. And then this is the reset. This is the when the operation start, they should store some value of D103. And then after that, here's the car parking spaces. What it does is, let's say what car parking space occupied, they're gonna be 1, and then after that they're gonna set the bit to 100, CIO 100, and then after that BCNT is a bit counter. You're gonna count how many bits are on, return the value, and then after that they do some subtractions. You can read up in detail here, and then the result would store in D102. And then after that, that D102 gonna be put inside the 7-segment decoder. It's gonna decode it and then show it into A, B, C, D, E, F, G of the 7-segment display. And this one is full and available, which is just simply a comparison between two register. And then this part is the car in gate part, which is really similar with the car out. Basically, it's playing with the timer. When you click car in, the motor will open up, and then after that wait for X amount of time, and then after that you're gonna close it back for the X amount of time. So yeah, very simple one. You can read in detail. I'm gonna show you the HMI. Alright, this is a working HMI, which is linked with the ladder diagram behind. Then okay, basically this is the start. When you want to start, let's say I'm gonna click start button, and then it's going to show 6 parking available because none of them is occupied. So let's say I'm going to occupy one OKU, one for the OKU. It's going to show at 5, and after that another one. Or this doesn't have to be sequentially. You can just randomly occupy one, and then it's going to show 3. And then let's say 3. Some people are coming inside the shopping mall, and then they're gonna look for the light. Oh, okay, I see this light is on. Then they're gonna straight away go inside this parking. So it's easier for them to, go one round and look for the parking space. The light indicate, oh, okay, there's an available line. Then you can just straight go in. So now it's 2, and then 1. Then still 1 parking available, and then you will see when I click. So now everything is occupied, the lights are off, then it's a 0 parking and it's full. Okay, let's start. Let's say, yeah, let's start. Click in. When I click, there's gonna be very fast timer, so you won't see the light blink. But what you will see is you're gonna see the motor rotation forward and the backward. So I'm gonna click in. It's gonna open for a while, and after that, hold it. Imagine this one is on, and after that it's gonna come back down again in a few seconds. Yes, here it's gonna come back down, and then it's off. So yeah, this is the identification of the motor rotation forward and backwards. So here it's also the same thing, and then after that hold for a while, and then after that come down again. Alright, this is the I/O diagram. We're using Omron CJ1M. We have an import and we have an output here. Input gonna be a sourcing, and then output gonna be a syncing. So on the input side, we have start, stop, reset button, and then car in, car out, and the 6 parking space. And on the output side, we have 7-segment display from A to the G, and then we have full and available. And then this one, it's car motor forward and reversed. I'm gonna show in the next page. Basically, it's a H bridge. On the left hand is for car in, on the right hand is for the car out. So basically, when car info is activated, we use a 9-volt battery to rotate the motor. The current will go through here, pass through this relay, and then after that pass through the motor from left to the right, and then after that it's gonna go to another relay, and then it's gonna go to the ground. So same thing, when you click when the car in reverse is activated, the current will go through this relay, and then after that go down. It's gonna go through a motor from right to the left in this case, and then after that go to the relay and to the ground. This is very simple, and yeah.